the identity function. This lets it know you're defining a function of one argument called x, and it just returns x. Let's say I want to define a somewhat more interesting function, a function that doubles an argument. Well, this is one way to do it. But I want to show you how I do local variables in my language, which is just using define again. So this works. To define here defines a local variable inside the function, not a global variable. So if I apply here, it doesn't know what I'm talking about. And then the last thing I'd like to show you, this just tells the REPL to start over. So now double doesn't exist anymore. I can also define modules, which is just basically a namespace. So A is a module in which x is defined to be 2. X isn't defined out here. If I import A, suddenly x is defined. If I ask what A is, it says it's some module. So that makes sense to everybody? Okay, cool. All right. Reset. Okay. So, right. Here's a small example file written in my language, which I'm just going to use, right? Which is exactly as if I had just written this at the REPL, right? So now I have modules A and B. Right? In A, it doesn't know what I mean. I have to import them first. So let's say I import A, import B. This one, some of you may be wondering, what happens when I do this, right? Since my last talk was in part about how Python and Haskell have different notions of scope. In Haskell, this would error. In Python, this would give me B. In my language, it gives me B. If it's like Python, it chooses the second one, the most recent definition. Okay, so now I'm going to do a bit of magic and show you what makes this language slightly special. Ignore the person behind the curtain.
What?
Ignore that line.
Oh.
Okay? Now, apart from that line, I've just done what I've done before. Import A, import B, in A and B, everything's fine so far. Okay. Wait, what? So, this is where that line came in. This line says, okay, for purposes of scope, treat in both specially. Instead of using your regular monoid, which just says take the second value when there's a conflict, use this monoid, which consists of the operator string append, which appends two strings, and the identity of this operation is the empty string, right? So when I import A and import B, they both define in both, and so it has to combine the values somehow, and it combines them using string append. Can everybody see that low on the screen, or should I lift it up? Okay. Okay. All right, so now if I define in both, again, any guesses as to what in both is now? A, B, Z, Z. Yeah. Right? And I can keep adding to it. I can't get rid of it. Reset. All right, so that's like the sort of most important thing about language. You define how scope works. I'm going to do a quick aside on how scoping works some more, not in a way related to this sort of monoidify operator. Just, if I define x to be original, then I define get x, which just gets x. Well, obviously that gets x. If I then redefine x, x is changed, get x still returns original. That's because when you define a function, it uses the values of the variables you refer to at the point at which you define the function. So when I define get x, x was original. So it uses that x, right? So that's important for understanding the next example. So here's some more example code. So this says names is a variable that I want you to treat specially for purposes of scope. And it's going to have the following monoid as its meaning of scope. going to set union for its operator, and this is the empty set. So set is just a function that creates a set of its arguments, right? Sets are a built-in structure in this language. And set union, so that's the set containing the elements 1, 2, and 3. If I join that with a set containing the elements A and B, I'll get the set containing 1, 2, 3, A and B. Right? So names is going to have to be a set, right? And a look at what it is. It's exactly what I've made it up there. It's a set containing the strings Ada and church. Right? Get names is unsurprising. With names is somewhat interesting. So what name am I supposed to use here? Okay, so this function with names takes an argument x, locally defines names to be x, and then gives me whatever names it is. So any guesses what this is going to return?
Add a church and hopper.
Right, yeah. So you might expect it would just give me the set containing hover. But no. When I define names x, it combines that definition, right? Because I've defined what scope means for names with the previous definition that it sees, which is that names is the set containing Ada and church. So, yeah. Names has not been changed, right? That is a local definition, right? It doesn't mutate what names is. It's just locally names mean something different than it does globally, based on the argument I passed. Let's say I define some more things. Define names. Now names has Ada, list off in church. If I run get names, well, like I said, it uses the value at the point the function was defined, so it doesn't see this new list off that I've added to the set. It just goes to that. And if I do with names, set, did I do that yet? No, whatever. Sure. I don't care. It just shows me, Ada, church, and Turing, right? It doesn't see list of 100. So names acts like a scoped set of names, right? What things are in it depends on what scope you're in. And for example, if you import a module, which defines names, that's what string was. Sorry. Right, so names is still Ada, list of church, but if I import everything from A, because of the import, I now see a new number of names Turing.